Hello meteorology students, welcome back. This week we start looking at weather maps. Weather maps seem pretty complicated at first, and so what we're going to do is break weather maps and the symbols that we use for weather maps down into two separate labs. There's conceptually not a lot to this. It's not a real heavy conceptual thing. It is, frankly, just a lot of memorization. So it's conceptually not heavy, just have to kind of know what you're looking for in these. So we'll break it down again into two separate labs here. In the first one here, we're going to run through the basic concepts behind how we set up these weather symbols, and then we'll look at some of the base symbols, some of the basic stuff, and then we'll do a little more detail, a lot more detail actually, in the next lab. So let's jump right into it. The idea behind this, and if you look at the map that's behind this image here, you just see a ton of numbers and lines and all sorts of symbols, and they all have a certain meaning, and they're all really important for displaying certain type of weather data. And so the idea behind this is to simplify it. Let's say we had air pressure, and we wanted to put air pressure on a map. So that's an example here. Well, that's great. But what if we also wanted to show the temperature, surface temperature, because that's really important too. And let's say we wanted to show dew point temperature, because that's also really important when it comes to weather and meteorology. And let's say we wanted to show how much the pressure's changed over the last 3 hours, right? That's really important. So the point with this is there's a lot of different data, and this is just 4 bits, that we would like to show, like to display in our weather symbols. And there's a lot more than just these 4. But we need to do it in as compact a space as possible, because we want to show as much data as we can. Frankly, even on this map, this is not a lot of data, right? Just go back to this image. I mean, look how much data there is here. And I'll be honest with you, even this is not all the weather reporting stations. There are thousands and thousands and thousands of weather reporting stations across the country that you could plot on a map. So how do we then take this data and display it in as small a space as is reasonably possible? Well, we do that through what's called synoptic weather symbols. That's what you see here. So the trick with this is, when you look at these symbols, is knowing what do all these numbers mean. You know, where do I find temperature? Where is pressure? Where is cloud cover? Where is cloud type? Things like that. That's what we're going to get into in this lab, in the next lab, is figuring out what all these things mean. Now, to get you going on this, you have this in your handouts. And this is sort of your key or legend, if you will, to what these symbols mean. So you have for a sort of a generic example here, and then this shows you what all these bits of information mean. So let's focus in on this and start looking at what these different symbols mean. Like, you know, what's that mean? What's the 998 mean? You know, what's that symbol? Things like that. So like I said, we'll get into some of this today, some of this we'll get into in our next lab. Now, just to start with, sort of the philosophy I've always had when looking at weather symbols and teaching it over the years is we are going to have this sort of circle thing here in the middle. And that center part is where I reference everything from. So for example, we can talk about, you know, what's to the left of it, what's to the left and above, what is directly above, what's to the right and below. So we can refer to different things relative to that center circle. So I'll do that quite a bit as we go through and look at these different locations of data on our synoptic weather symbols. So we have our example here, our sort of key or legend here. So let's start then. If we have to our left and above, we have this number here, this example, 77. Well, what is that? What does that tell us? Well, let's look to the left and go above. Well, that's the letter A. And in that handout, turns out A is the temperature in this country going to be in degrees Fahrenheit. So again, to the left and above is going to be our temperature, again in this case, in degrees Fahrenheit. And as we go through then the rest of these here, letters, we look at B. So B, we have B1, 2, and 3. These are going to be our clouds. B1 are going to be our low-level clouds. B2, mid-level clouds. B3 are high-level clouds. And those clouds have certain symbols. The cloud symbols we'll get into next week, but that's just what those are. C is going to be our pressure. So to the right and above is pressure. And again, I'm going to go through pressure in just a second here because it's a little bit to pressure. Visibility is going to be directly to our left and all the way to our left is going to be visibility. So in this example here, it's 5 miles. E is going to be our present weather. So you see this symbol here, it's going to refer to some sort of weather condition. Again, that's a symbol we're going to get into next week, but just know for now, that's where our present weather symbols are found. F, so what this circle shows us, F, is the cloud cover, and we divide it into 8s. So basically the idea is you look up in the sky, divide the sky essentially, for how much of it has clouds, how much doesn't have clouds, and report that in terms of 8s. So 1/8, 2/8, 5/8, 8/8, whatever it is, report it in terms of 8s. Easiest way to do that. And again, I'll show you that in just a second. The pressure change and tendency, we're going to find directly to our right. So pressure change is going to be the numbers you see here, and the tendency is going to be this little symbol, this line that you see here. Dew point is going to be to the left and down. So in this example, 71 degrees Fahrenheit is our dew point. Past weather is going to be down and to our right. It's going to be our past weather symbol, so it's going to be a separate set of symbols for those. Again, we'll get into those next week. And then the little stick that you see here with the tick marks on the end of it, that shows us our wind speed and our wind direction. And again, I'm going to get into that in just a second. So that's what all of those mean. It's where to find them. And I should also say too that when you're looking at examples, you're not necessarily going to see everything that you see here. For example, here in Southern California, we often have cloud-free skies. And so you're not going to see cloud symbols. Right? They're just not, there's going to be blank. There's nothing there. So you won't necessarily see everything that you see here. It simply depends on what's happening that day in the atmosphere. All right, let's start then with our center point, our cloud cover. So think of this as a graphic representation of what's happening in the atmosphere. If your circle is clear, no clouds. If there's one little line, that's 1/8. 2/8 is going to be like a quarter of it taken up, because 2/8, reduce that fraction, becomes 1/4. Okay? 1/4 with a line down, that's 3/8. If half of it is colored in, that's 4/8. The line over there, 5/8. 6/8 is, you reduce that fraction, it's 3/4, so 3/4 of it is covered. With just a little white line down the middle, 7/8. And if it's completely colored in, it's 8/8. Should also mention, if you see a X across it like that, that means the sky is obscured. That could be because of a low-lying fog layer or smoke. Certainly smoke, as you're probably well aware of around here in Southern California, can obscure the sky pretty darn well. And so the actual clouds sometimes become hard to see if you have a really thick smoke layer. Now, one thing I just want to emphasize is we do report this in 8s. So if you see an example that looks like this one, 4/8, don't report it as 1/2. Report it as 4/8. So even though you can reduce the fraction, doesn't mean you should. Right? So just keep it as, again, in 8s. All right, next common one I want to talk about is the wind speed. So these tick marks on the end of our stick here tell us the wind velocity. It's relatively straightforward. A long line is 10 knots. A short line is 5 knots. if you see a triangle, you won't see that very often, but if you see a triangle, that's 50 knots. That's a really strong wind, so that's why you don't see that often. Now, truth be told is, for example, in this one here, we see that there's a 10 and a 5 for a total of 15 knots. Now, does that mean that it's exactly 15 knots? No. Technically speaking, what that means is it's somewhere between 13 and 17 knots. But we just say 15 knots, with the understanding that it could be 14, could be 16, could be 17, could be 13, right? But we just say 15. Now, I'm a big metric fan, big proponent of the metric system. If you want to memorize these in kilometers per hour, you can. If you want to memorize them in miles per hour, you can. But this was designed with knots. So the easiest way to learn this is simply to learn the knots, because it's much easier. Short stick, 5 knots. Long stick, 10 knots. Triangle, 50 knots. And so you simply just add up the total of those number of your tick marks. So, and again, the table here is going to show you and explain all that. Relatively straightforward, but like I said, just learn the knots. Not a big fan of knots myself, but it's the easiest way to do this. Now, we also have wind direction associated with this. So you see our tick mark here is between east and south. So we would say it is a southeast wind. It's a southeast wind. When you're doing wind directions, it is always the direction the wind is coming from. I can't emphasize that enough. Wind direction names is the direction the wind is coming from. So in this case, because the stick is between south and east, it is a southeast wind. It is coming from the southeast. So in other words, it'd be blowing like this, going to the northwest. But we call it a southeast wind. Again, I'll say it again. Wind direction names are the direction the wind is coming from. And again, your handout explains that in a little more detail, different ways that we can express that. But that's our standard nomenclature that we use. Now, just to clarify with this, if I had something that looked like this, this would be a wind that is a northeast wind at 5 knots with 3/8 cloud cover. That's what that symbol would tell me. Okay, so again, north, east, south, west. The stick is between north and east, so it's a northeast wind. Should also mention we always lead with north and south if they're in the direction name. So you wouldn't say it's an east-north wind, it's northeast. So you always lead with north or east if it's in the name. Now, it could just simply be an east wind. That's fine. It could be an east-northeast wind. That's fine. But if you're talking about just a two-name designation, you always start with north or south. All right. So that is our wind direction. Pressure. Pressure is a little different. It's the one thing that's, I wouldn't say conceptual, but you have to do a little trick to get the pressure. All right, with pressure, you will notice on this particular example, we have 3 numbers. In this case, 998 is our pressure. So, let me make this a little bigger. So I'm going to show you what to do here, and you do the same thing every time for pressure. You do the exact same thing every time. First thing you do is you put a decimal point between the last 2 numbers. So in this case, between the 9 and the 8. Then in front of this, you're going to put either a 9 or a 10. So this is either going to be 999.8 millibars, or it's going to be 1,099.8 millibars. Now, the obvious question, which one is it? You pick the one that makes it closest to 1,000. So you pick either the 9 or the 10 to put in front that makes this total value close to 1,000. In this case, 999.8 millibars is very close to 1,000. 1,099.8 millibars is very far from 1,000, and in fact would be the highest pressure ever recorded on the Earth's surface. That would be a record. So that's the general rule of thumb, is you pick the one that makes it closest to 1,000. And again, I can't emphasize, you do the same process every time. Decimal between the last two numbers, regardless of what they are, 9 or 10 in front. Now, here's where people usually get kind of messed up with this. And it has to do with zeros. So for example, let's say instead of this, it was 0, 1, 0. Let's say that was your pressure numbers that you had there. You do the exact same process. 0, 1, 0. I emphasize this because people like to throw away zeros. Do not throw away your zeros. People think zeros are worthless. They are placeholders. They are very important. So you put decimal point between the last two. You keep those zeros there. And you simply add a 9 or a 10 in front. In this case, a 10 to make this 1,001.0 millibars. But again, if your three-number designation here has zeros, do not throw out the zeros. Keep the zeros. Decimal between the last two, add a 9 or a 10 in front of it. That will get you your pressure reading. Now, why do we do that? Because we're trying to compact this into as much space as possible. And I can guarantee you 99.999999% of all pressure readings you come across are 900 and something or 1,000 and something. Technically, can it be 800 and something? Yes, but you might get one or two of those a year. And they're going to be hurricanes. And if you have a hurricane, you're going to have really high winds. You're going to know it. So don't worry about 800 pressure readings. You're not going to come across them, basically. So that's why this little rule of thumb works quite well. All right, so that's pressure. So all of this is laid out, again, on your weather map symbols chart here. Like I said, what we're going to deal with next week are going to be the present weather symbols, the cloud symbols, some of those sort of things. But for now, we're mainly just focused on what these numbers are, where to find them, and what they mean. That's what we're focusing in on. So primarily, we're looking at this week cloud cover, wind speed, wind direction, temperature, dew point, pressure, pressure tendency, and pressure change. These ones here. For the most part, the rest of the stuff we're going to deal with next week. All right, so it's a quick intro. Like I said, conceptually, not a super hard lab this week, but you do need to get familiar with this. You want to be able to quickly be able to find temperature and dew point and those sorts of things. Be very proficient at doing that. All right, as always, any questions, let me know. Otherwise, good luck, and I'll see you next week.